Greetings. My name is Akhil Pamarthi, and I'm a student of your CSCI 54901W Automator Theory. And this is my video presentation for the project. Let me share you my screen and explain about the description. Well, as we can see, the purpose of the project is to develop an application that allows users or the customers to book flights for the trips. The main purpose is to ask the customers for the flights. I mean, the information such as the airlines or the timings they prefer, all such events like this. We can communicate with the as per their tastes and preferences. To perform this project, we are using this CKY parsing algorithm and a context-free grammar membership algorithm. This determines whether or not a particular string corresponding to the grammar language. It is also known as CKY algorithms or Koch-Younger-Kasami algorithm. In order to use this algorithm and determine whether a string is in grammar's language, it employs a dynamic programming language technique. Grammar rules are applied to substrings of increasing length in the CKY algorithm. Since the upper bound of the early approach is the time complexity will be lower, and the CKY algorithm has a time complexity of 0 and 3. Now, the following are few sentences that will be passed using CKY using the project, which are used in the project, such as can I book a flight? Do you need this flight? I need this airlines. Or can I cancel the flight? Can I book the flight? Book the flight for California. Do you prefer the airlines? Do you need the flight? I need this flight. I want this flight. Book this flight for me. And all such sentences. Um, in these sentences, few of the sentences are not correct. Let's say, this is the flight I want. This flight can. This is the flight I need. Flight me. These are all the sentences which are not valid or which are not correct. Uh, in our list of sentences. Now, coming to a little bit more about the description, we all know what CFG means. CFG is nothing but a context-free grammar language. Uh, as we can see, these are a group or a set of CFGs, context-free grammars, where we don't have any context. We just have a small, you know, s- we have a little bit of information, let's say short forms. It also has some non-dominant to dominant values. Let's say S is a non-dominant, SNP or VP is a dominant value. We have to convert these context-free grammars to Chomsky normal forms. And Chomsky normal forms does not have any null products. So to continue further with the project, we all have to do is to convert these context-free grammars to Chomsky normal forms, which will be utilized in our project. So these are a set of context-free grammars, and after conversions to the Chomsky normal form, they are as follows, which we can see it like this. So these are all the context-free grammars converted to Chomsky normal form. Now let's go to the CKY tables. CKY tables are nothing but Koch-Younger-Kazami algorithm tables. In these tables, we usually have this thing, the right upper diagonal most box. Let's say this S, uh, and all other values can be found from the bottom to the top, something like this, something like this, something like this, and something like this. So usually this happens from bottom to the top. The rightmost top box decides whether the given sentence is a valid or not from the particular grammar. So this is the decider factor. It decides whether sentence is valid or not. If there is an S in the box, then we consider that the particular sentence is valid. If we don't have S or anything else, or if there is any other word or sentence in this rightmost top box, then the particular sentence is not at all accepted, or let's say the sentence is invalid. Now let's go through our examples. Let's say, can I book a flight? Can I book a flight? As you can see, all the given sentences, all the values can be found from bottom to the top, as we have discussed earlier. And there is an S in the rightmost top box, which means um, the sentence is valid. Now let's go to another example. Do you want this flight? Do you want this flight? Here, same is the case with this one as well. All the sentences are from bottom to the top, something like this. And there is an S. We got an S in the rightmost top box of this sentence, and we can conclude that this sentence is also a valid one. I need this airlines. Well, this is a tricky one. I need this airlines. Even though all the sentences here come from bottom to the top, something like this. And in the rightmost top box, we have S, A, P, and N, D, which means we are having an S in this box. So this sentence is also a valid one. Now, what is the airlines? What is the airlines is the same as well. All the sentences are found from bottom to the top, and there is an S in the rightmost top box. So this sentence is also a valid one or the correct one. So here are few examples uh, for the Koch-Younger Kasami algorithm, or these are the few tables for all the sentences where you can see clearly that there is an S in the rightmost top box, and all the sentences are observed from bottom to the top. All of these examples have either S or S comma A comma NP. And let's get to this one. This is the flight I want. This is the flight I want. All the sentences are from bottom to the top. That rule has been satisfied, whereas there is no info or nothing in the rightmost top box. If we have an S, then it will be considered as a something like a valid statement or a correct statement or a correct question. But if we don't have anything, we can come to a conclusion that it is not valid. So this sentence is not a valid one. This is the flight I want. Even this flight can. Even same is the case with this flight can. All the sentences are now from the bottom to the top, and also there is no S or any info in the rightmost top box. So this sentence is also an invalid one. Same is the case with this is the flight I need. There is nothing in the rightmost top box, and this can be concluded as an invalid or incorrect statement. Flight me. Flight me, there is a B in the rightmost top box, which is also an invalid or incorrect statement. Now let's come to the coding part. I have used Python to uh, code for this particular project. Now, as you can see, this is the code which I have created. And after creating the code and running all the sentences or all the valid statements, or let's say the statements, I have captured few of the screenshots stating whether the statement is valid or not. Now let's talk about each and individual sentence separately. Can I book a flight? I have entered and the response which I have got is an yes. Do you want this flight? And same is the case here. I got a response as yes. After completing the code or after writing the code, the using the CKY algorithm, the code generates a statement, or let's say the output, stating yes or no. If the statement is valid or correct, it states or gives out the output as yes. And same is the case with the vice versa. So these are all the few sentences or few outputs which I have captured the screenshots and shared with you. Let's say, can I book flight tomorrow? And the caption or sorry, the output is an yes. Enter a sentence for book for flight for California for yes. Yes. Do you prefer this airlines? Yes. Do you need this airlines? Yes. So these are a few examples for an yes or in or a correct statement. Now let's go to the invalid sentences. This is the flight I want. Enter a sentence. This is the flight I want. It states no. As we have seen above in the as we have seen previously, if we have entered after entering these sentences, we have got no proper response in the rightmost top box. Either if there is no S or if there is some other letter in the rightmost top box, we will be getting no output. I mean, we'll be getting the answer as no, stating that the sentence is invalid or incorrect. Same is the case with the other one. This flight can. Even the answer is no, this is the flight I need. The answer is no. Flight me. The answer is no. So this is all in brief about my project and its description. I'm recording this video and I will upload the YouTube link in the project description as well. Thank you so much.